In the last one, we finished off up to, let's say, the derivation of the formula EMF is equal to IR plus little r, right? We went through that thing and we showed that it's not really anything, anything special or untoward. All it is just a straightforward formula derived from V equals IR. Okay, now, how do we solve these problems? We're going to solving problems. Let's have a look. Well, as usual, I didn't check. Okay, let's get this sorted. Okay, let's have a look at solving a problem. Okay, we've got quite a few to do. All right, let's first of all, I'm just going to say that we have got a cell over there, we've got an ammeter over here, we've got a resistor over here, and we've got another resistor over here. I think I use 6 ohms and 6 ohms, and then I've got a switch there and a switch there. I called that S1 and that S2, and we went back up like so. All right, now let us say that here we have got an EMF of 12 volts. All right, now if both switches are open, it means no current's going to flow. We know that, okay? But if I put a voltmeter across there, I will read 12. How do we go about these? First of all, we put the current in, I is going there, and I is going to split. But I know that I've got 2 switches, so I'm going to have 2 scenarios, aren't I? We're first going to solve it, and it says here, oh, let me just finish. If we put a voltmeter connected there and there, like that, we will read 12. Why? Because this side, all the positive charge is there, all the negative is there. So there's a high point there and a low point, the plus and the minus, okay? It's the same, remember, as water, okay? Or in fact, geography, atmospheric conditions, high pressure to low pressure. Okay, so now we do that. Let us now have a look what they've said. If S1 is closed, let us look at the 2 scenarios here, okay? Scenario 1 is S1 closed, okay? Therefore, I say that V is equal to IR, 12 is equal to I times 6, I is equal to 2 amps, right? Now we say S1 plus S2 are closed. All right, so now I've now got a parallel resistors, so we must first find the equivalent resistor in the middle over here. Remember the ghost resistor? Let's find that equivalent resistor. I say first of all 1 over R effective is 1 over 6 plus 1 over 6, which is going to be equal to 2 over 6, which is going to be R effective is equal to 3. Okay, therefore 12 is equal to 3I, I is equal to 4 amps, right? So that 4 amps would be coming and it will split and we will get, let me put it in, right? Straight away I know that's 2 amps and that's 2 amps over there. It splits equally because of equal resistors. Okay, we know that. Now, the next step, we said, now let's say the battery has an internal resistance. Okay, I'm now going to put in an internal resistance in green. I'm going to say either like that, R equal to 1, or they would say EMF, R is 12 and 1, like so, right? That shows it's volts and the ohms. Okay. What do we do next? Well, next again we have 2 scenarios, right? We have S1, I'll do it in green. Okay, S1 closed. All right, if S1 is closed, what happens? Now we have EMF equal to I, R plus little r, which is going to be, I is R, which in this case was 6 plus 1, remember? And that is going to be 12. So therefore, I is going to be 1.71 amps. Because this is my R load circuit, this is my R internal, okay, or lost. Now S1 plus S2 closed. What do I do? S1 plus S2 closed. Straightforward. I say same again. What is R load? Okay. R load is going to be equal to, let's have a look. It's 1 over R plus is equal to that 1 over 6 plus 1 over 6, correct? That gives us R equal to 3. But R load is 3, R internal, or R, the little resistor, little r, is 1. Therefore, R circuit equals 4. Therefore, EMF is equal to I times 4. 12I is going to be 3 amps, right? Remember that? 12 is going to be equal to 4I. Therefore, I is equal to 3 amps. Now, there are questions in most of the textbooks involving lamps and brightness. Okay? Obviously, these resistors that I have just used, okay, I could have replaced each of those with a light bulb and given you the 6 ohms for that. Then they'll ask you what happens with if the internal resistance is not there and what happens if the internal resistance is there, right? They could give you an experiment to do with it, and then you have to say what happens at the brightness. And remember, the brightness of any bulb is linked to the power. Okay, brightness, it's on blue, it's fine, is linked to power, which is VI, V squared over R, or I squared R, right? And you can see that if there's an internal resistance, the current drops. Why did the current drop? Because I'm squishing it. I can't let the water flow through. It's not coming through properly, right? Okay, dokes. Now, let's talk about another favorite question, okay? They say to you, given some apparatus, or not even necessarily given some apparatus, okay? They say, how do we find the EMF and the internal resistance of a cell? It's generally an experiment, okay? And it is to find EMF and R of a cell. Okay. What do we do? Essentially, we have a circuit that looks like this. I'm just going to draw it on this side. Just going to check here. We've got this going here, and we've got, there's our cell. Forget how many, it doesn't matter. There's my little R taken out on the side. Okay, I put over here, this is my cell. Okay, that's the little cell there. Okay, I put over here, I put an ammeter, and I put over here one of these jobs. All right, and then I put over there in line, I put a switch like so. All right, that's for mainly for safety's sake. And then I put my voltmeter across here like that. This over here could also be something that looked like that. Okay, it is a variable resistor, also called a rheostat. Okay, spelled R-H-E-O-S-T-A-T. It is a variable resistor, because normally the resistors come, they're small little things with a piece of wire on the outside, and they've got little color bands, and the little color bands tell you how many ohms the resistor is, right? This one you can vary it by turning it, okay? And what we do is we now, okay, we read the voltage with the variable resistor on maximum, all right? And or with the switch open, close the switch and read points V and A. So we read this. We get a table of results. Results. Okay? We get a table of results that look like that. And we've got current, okay, I, measured in amps, and we've got voltage, which is V, measured in volts, okay, we know that, and we get a set of readings, okay? That's basically what we get. Now, as we go and we vary that, we read V and A, all right? So these are our pairs, V and A. So this is going to be reading of amp 1, V1, amp reading 2, volt reading 2. So we get our coordinate pairs. The next step is we plot a graph. So we plot a graph, okay, of this. We plot the graph of V versus I. This is the x-axis here. And this is the y-axis up here. Now we plot our points, okay? I'm just going to take some arbitrary points there. We plot a set of points. That is the graph, is it not? Okay? Then we come along and we extend the graph backwards, like so. Because this corresponds to a current of 0 and a EMF. All right? That corresponds to the EMF of the cell. So they've given us these over here. We read them off. Yes, you could do it basically by putting the rheostat right down, but that is our experimental result there like that, correct? Now, let's have a look and see something. Okay, just give me a second. Right, what we've got here is we've got our experiment. Okay, yes, sorry. We've got the experiment. Now, if you remember, we've got EMF is equal to I times R plus I little r, correct? Therefore, IR is equal to minus IR, okay, plus EMF. All right? But this IR here is V load is equal to minus R times I plus E. All right? Just look, this is my V load, is my y-axis. This over here is, EMF is there, V load, okay, is equal to M X, okay, plus C. My x-axis is my current. So you can see that V load is equal to minus RI plus E. This is equal to the gradient. So what do? We come along and we read the gradient. All right? And the gradient, M, is equal to minus R. So therefore, you will get a negative number. Let's say we get minus 2, and the gradient is minus R, so it's minus 2, which is going to be 2 ohms is your internal resistance. And E over there is your Y intercept. Okay? Please note this because you're going to see this coming up again and again, right? It comes up in the when we do the photons, all right? The optical section where we add the the electronic effect where we bump off a photon. Just escaped me. Threshold frequencies, photoelectric effect. That's the one. When we get to the photoelectric effect, you're going to do something very similar. So it's a great exam question. Either this one or the photoelectric effect one, we do the same thing. we change it around, write it in the form of y is equal to mx plus c, and we take it from there. Okay, now let's have a look at a different example, shall we? Let's go for another example. I hope everyone is happy with that. It's very simple. All you do is you plot the results, extend it back, that's your E, and your slope is your minus R. Right, let's just have a look at the following circuit, all right? They've given us the, right, 2 and 4. I've done one with 2 and 4 over here. Okay. All right. All right. Yeah. Let's take this one over here. Right. Here they've given us a, let me just move that up. You know what? Probably going to have to do this one like so. Example 1. All right, let's see. We've been given this circuit here. Okay, and they've told us R, and they have told us that we have a 2 ohm resistor here with a switch. Can you see? Very similar to the one we just did. Okay, just going to, and a 6 ohm. Like so, and, oh sorry, a 4, my bad. A 4, it's a 4 ohm over there. 4 ohm resistor over there. And I've labeled this switch 1 and switch 2, okay? Right, and they say, what is the ammeter reading and why? Okay, Kevin has got to put in the ammeter, and let's put it in over there. All right, and then they say a voltmeter is placed across X and Y. What does it read? Well, it reads the EMF and R. So a voltmeter will read, it would read E volts. We don't have a number, but it reads E volts. Okay. Now they say switch S2 is closed and the ammeter reads 2 amps. Okay. Then and 4 amps when S1 is closed. So what they've done is there's 2 scenarios here. All right. I am going to draw the 2 scenarios separate. So just give me a second just to draw this. You can draw it while I do. Okay, EMF, R. The first scenario had an ammeter and I equals 2. I've done it in black, but I should do it there. And we had a 4 ohm resistor here. And basically that's the circuit we've got. This is scenario 1. Scenario 1. Okay, that's what they've given us for that, isn't it? Okay. Now for scenario 2, they gave us the following. Said, okay, there's my ammeter, and over here, here's our cell again. Okay, with its R, EMF, and R is there. Then we had our 2 ohm. We had our 4 ohm. All right, and these 2 then went over there, like so. This is scenario 2. This is scenario 2, isn't it? Right, and they told us in this one, reading is 4 amps. So what is the rule? The rule is put the current in, and then let's start from there. Okay, because they have asked us to calculate what is the EMF and what is the R, the internal resistance of the cell. How do we do it? You split them into the 2 scenarios, okay? No, you can't just apply formulas. Draw it. It makes sense. Okay? I mean, it's quick to draw that with a pencil. Come on. Right? So we say, okay, scenario 1 then, right? Let's see, right, scenario 1. Now we've got an internal resistance, so we must start off with, done it again. We start off with E is equal to I times R plus little r. EMF, we don't know. is equal to I, 2 times R is 4 plus little r. So the EMF is equal to 8 plus 2 little r. Okay, that's straightforward, isn't it? Then scenario 2. Okay, now scenario 2, we've got the 2 resistors. So once again, I'm going to have to find R effective. Okay, this guy here. So what do? I say 1 over R effective is equal to 1 over 4 plus 1 over 2. So I end up with R effective being equal to 4 over 3, because that is going to be 4, 1 plus 2, which is 4 over 3 ohms, correct? So now I can apply my EMF formula. EMF is equal to I times R plus little r. So I say, okay, EMF is then going to be equal to 4, this is my EMF, is equal to I is 4 times 4 over 3 plus R. So EMF is going to be equal to 16 over 3 plus 4R. Now, this is now equation number 2. And, yep, this one is equation number 1. How do I find them? Simple. I just equate them. Right? So I put the 2, and I'm just going to read it off what I did here. I said here that 8 plus 2R plus 2R, this is equation 1, must be equal to 16 over 3 plus 4R. Okay? And rearranging that lot, I got 8 minus 16 over 3 equal to 4R minus 2R, and you end up with R equal to 1.33 ohms. How do I find the next? I back substitute. Into, doesn't matter, whichever one you like. I used EMF is equal to 8 plus 2 times R, which was 1.33, which comes out to be 10.66 volts. Okay? Very such straightforward, not too difficult to do. What do we do now? Can you see the whatchamacallit of that one? It's pretty straightforward, isn't it? Okay. Now, so now I've solved for that, 2 simultaneous equations. But the method is the same in each case, right? Okay, I'm just going to pull down for the next one. All right, whoops. Okay. The next one is another example, is the following. All right. They've given us a circuit over here, and they've told us that I've got the following. And I'm just drawing a number of cells there, and they've said EMF is equal to 9 volts, R is equal to 2 ohms, and down here we have got an ammeter, and inside here they have given us 3 identical bulbs. Okay? And they have located over here a point A and a point B. They say in the above circuit, each lamp is identical. Very important. Okay, we say lamps identical. All right. Now, remember what we said. Always read what you are given in the text. Don't just look at the drawing and say it's all there. It's not always all there. Okay. So we say, all right, they've said to us that each lamp is rated or has got the following: 3 ohms and 0.5 watts. What are they saying? They're telling us R and watts is power. Okay? Okie dokes. So first thing we do is we start off and we put in I, and this goes to I1, I2, and I3. Right? That's what we've got there. Note, we've got R, but what can we do first? Well, we can calculate the what? The resistance, can't we? All right? Because we know that the resistance is 3 ohms. So therefore, we calculate it. How? It's 3 in parallel. So we go 1 over R. Effective is 1 over 3 plus 1 over 3 plus 1 over 3. The answer is going to be 1. So R effective is equal to 1. We now know, therefore, that the EMF of the cell is equal to I times R plus little r. We've got a little r. So the EMF, they've told us, is 9 is equal to I times R, 1 plus, and little r is 2. So therefore, my current 9 is equal to 3I, I is equal to 3 amps. Okay? So the ammeter reads 3 amps. That's cool. What next? Next we say, what is the reading on the voltmeter? Now, where's my voltmeter? I'm going to put in the voltmeter. Because remember, the voltmeter reads V load. Okay? It's reading V load. Okay? It reads the circuit voltage, or V load. So, okay, reading, okay, just take it up again. V load must be equal to I times R. This is the R circuit. Right, so V load, or the reading on the voltmeter, is going to be equal to 3 times 1, because remember the circuit resistance was 1, which is going to be 3 volts. Okay. Now let's have a look. What is V lost, or V internal? Is going to be equal to I little r. I is 3, and that was 2, which is going to be 6 volts. Therefore, check. 6 plus 3 is equal to 9 volts, which is the EMF of the battery. So we've got it sorted. Okay, because remember, we had our battery over here, and in this case, we've got V load equal to 3 volts, and that 6 volts is V internal, or V lost. Now, let's have a look. Calculate the maximum permissible current in each bulb. What are they talking about? Let's just look here. They've given us that. They want to know the maximum permissible current in each bulb. What does it mean? It means that the current flowing through that bulb, neither the voltage, the current, those two are variables, right? Because R is fixed. So V and I are going to vary. So what do? We say that the power is the limiting factor here, isn't it? Makes you think of a chemical reaction, doesn't it? Limiting reagents. So power is equal to VI, I squared R, or V squared over R. And in this case, we have been told that the power maximum is 0.5. That's our max. And that's going to be equal to I squared times R. Okay, therefore I is going to be 0.5 divided by 3, all to the power of a half, or square root it. And my answer is 0.408 amps. You may wonder, in a lot of the textbooks, you don't get numbers like I use here. The reason for this is, first of all, is that it doesn't always work out as beautifully simple as 2 and 3 and 5s and so on. But when you go to university, no. You're going to find, or A-levels, you're going to find that the numbers you get are not pure and beautiful and simple, especially when you end up in a laboratory for physics or chemistry and things change. because you don't get things working out perfectly anymore. Okay? They work out, you do get 0.408 amps, 0.42 amps, or whatever the case might be, 0.41 in that case. Okay? So, then it says, what's going to happen in the circuit? What is going to happen in the circuit as it is currently? Okay? The current, as the circuit is at the moment, the current flowing down there is 3 amps. This is 3 amps, guys. So as this 3 amps gets here, what's I1, I2, and I3 going to be? Yep, they're going to be 1 amp each, aren't they? So as the circuit is at the moment, we are going to have this situation. Okay? We are going to have this. We're going to have 3 amps coming down, and it's going to split through our light bulbs, and we're going to have 1 amp, 1 amp, 1 amp. Hallelujah. What's that amp going to do? Boom. The current is too much. Okay? The maximum current is 0.408 amps that we've calculated there. That was the power rating. So that's all it can be. Okay? So our next step is to say, okie dokie then. Now we've got a bit of a problem. What have we got to do? Okay? We've got to throttle it back. We have to put in a resistor. So they say, point XY is available to insert a resistor to reduce the current. So what are we being asked to do? Let's just go here. We're being asked to put a resistor in here between point A, B, or XY. All right? Stick a resistor in there. That is going to reduce the current, isn't it? They want to know, calculate the value of this resistor. In other words, calculate R so that the maximum current flows through, or that the bulbs shine equally bright as they can. So therefore, what do we do now? We say, right, we've got I1, I2, etc. But no longer is that 3 amps. Okay? I can now go to my little diagram over here and use it. All right? Let me not, because that's going to we just rather just do another one with the stuff that I'm doing. All right? Let's just quickly draw it. I know time is marching. Okay, there's our bulb. There's our bulb. There's our bulb. While I'm drawing this, it gives you time to go and have a cup of tea. Okay, boom, boom. Internal resistance. They've told us this is 9 volts EMF and R is equal to 2. Okay, and each one of these. Now, they've told us that the maximum current here has got to be 0.408. 0.408. So what do I have to do? Okay, I know it goes dark because I'm blocking off the light to it. Okay, what do? I, in fact, then say, right, maximum current through each bulb is 0.408 amps. Therefore, total current must be 3 times 0.408 amps. Right? Because the current down here is going to be, red is I. There's my ammeter, sorry. This is I. So I is going to be equal to, and I worked it out here, 1.225 amps. 1.225 amps is there. Right? So we now know that. Now, let's then go back up and see what we can do with this. Right? We have got this scenario. There's our diagram. Total current is that. What can we say? Okay. I'm going to have to just work it from my, otherwise I'm going to be going up and down all the time. So I'm going to say here, total circuit resistance. Total circuit resistance, right, is R total. Is going to be 1 ohm This is the bulbs. Plus 2 ohms, which is internal resistance, plus RAB or XY or PQ, the unknown resistor. All right? So that's the R total. Now, EMF is equal to I times R plus little r, or which is R circuit, which is going to be 1.225 amps, that's our maximum, times 3 plus R AB. Correct? That's what it is. Or Rx, unknown resistor, if you like. This gives us 9 is equal to 3.674 plus 1.225 RAB. And you work out RAB and you get 1.775 ohms. Okay. So if you put a resistor up here of 1.775 ohms, it will throttle the current to be equal to 1.225 amps. Okay, that is one of the other kinds of problems. Okay, now remember, we're going to add some more. We're going to do some old papers. Okay, all right, I'll leave that one. I'll come back to it when I add a few more in. The next section we're going to do is we're going to start looking at electrodynamics, which is motion of motors and of generators. I'll see you in that one. Thanks for looking. Thanks for watching, rather. Please enjoy, do them. Remember with the circuits, okay? Put in what you're given, put in the current, and solve. If you know the total resistance, solve for it. If you don't, put in the little r or the big R, as I've done here. But don't get into the flap about it, okay? It's not necessary. It's just a normal resistor. Cheers, have fun, bye.